that are special. And what makes them special, you ask?
What makes them special?
Well, what makes them special is they're just exciting and fun triangles. I really don't know what makes them special. Take a look at this triangle here. Let us start off with a equilateral triangle. That's kind of special, don't you think? What do you know about equilateral triangles? Besides they have all equal sides, let's go one step farther than that because that's what equilateral means. Alex?
Triangle is 180 degrees.
Okay, that is true, but all triangles are that. That doesn't make, that would not be a special only to the equilateral triangle, that is special to all triangles. Equilaterals, Cameron?
Each angle is the same.
And what is that? Since all angles add up to 180 degrees, each angle is? If I do the math there, David, it is 60 degrees. Okay, the first special triangle we're talking about is not an equilateral triangle. It is what we get when we cut an equilateral triangle in half. Okay, an equilateral triangle in half. I'm going to do that right now. By the way, let's just for fun's sake, wow, did I just do that? I'm about to get real. Just for fun's sake, I am going to pick a side. I'm going to start my equilateral triangle with each side being 2. Whether it's inches, feet, miles, or decimeters, I don't care. Okay. My special triangle is going to come when I cut that bad boy right down the middle. I'm going to chop them right in half here, and I'm going to redraw that triangle. It's going to look like this. And I know this angle was 60 degrees, correct? I said I drew it right down the middle, and I made this a 90-degree triangle, or angle. It is 90 degrees. What is my third angle there? 60, 90, the other one has to be, Brooke-Kala is going to jump on this one. How many degrees? 30. And that, ladies and gentlemen, is special triangle number 1. Special triangle number 1 is a 30, 60, 90 triangle. 30, 60, 90. In the construction world or in the world of geometry, anytime you see 30, 60, 90 in your mind, a little light will go off and you go, oh, that is a special triangle. Now, here is why it is special. Okay, remember I said I made this side 2? Okay, if I make that side 2, how long do you suppose this side is? Since I took this and cut it in half. 1. And then, how in the world, I want to find out what this side is. How do you suppose I can find out what that side is? Give you a clue. The same thing we always do when we have right triangles. It's Maggie going to be? Right. Now, and this one's not a triple, I don't believe. If you look up there, there is not a hypotenuse that is a 2 and a side that is 1. So we're actually going to have to do it. So bear with me here. Pythagorean theorem says a squared plus b squared equals c squared. Right? Here's my a, 1 squared. I don't know my b, but I do know my c squared is 2 squared. So 1 squared plus b squared equals 4. How do I solve that? Subtract my 1 squared is 1. Subtract my 1 over, subtract my 1 over. I would only hope that you could remember and tell me what the answer to that is. If b squared is 3, what is b? If b times b is 3, what is b? Alex? It is not. That's cutting b, that's cutting 3 in half, and that's not what we're doing here. We're saying what number times what number gives you 3. Alex?
Square root of 3.
Second time is the jump. b equals the square root of 3. Okay? b equals the square root of 3. Now, it's at this point that you're going to say, so what? Okay. Okay, I'm glad you said that, because here's the deal. Just like with Pythagorean triples, you have a base triangle that you can find a whole bunch of other sides out, you know, like a 3, 4, 5 triangle is also a 6, 8, 10 triangle is a 9, 12, 15, you know, multiples. Same thing with this. This is your base triangle, and write this in your notes so that you see it nice and clean and good. Your 30, 60 triangle is going to start off always with a 1 down here, a 2 here, and a square root of 3 here. Which is easy to remember because it's 1, 2, and 3. Okay? And your so what ends up with this right here. Do you see, anytime from this point forward you're given a 30, 60, 90 triangle, you will be able to spit out the dimensions of it without doing hardly any work at all. For example, here is my new, I'm going to do another 30, 60, 90 triangle. Okay, I have to be given my 60, my 90, 30, right? If my 30, 60, 90 triangle has this side of 10, automatically I can tell you what all the rest of the sides of that triangle are because it's the equal ratios and proportions of this. See how this is 1? Okay, what do you do to 1 to get 2? You multiply it by 2. What do you do to 1 to get the square root of 3? You multiply it by the square root of 3. So this is the same thing I do with 10. This side has to be how long? Well, from 1 to 2 you double it, so this side has to be 20. And this side over here has to be, no, it's 10 times the square root of 3. Because this was 1 times the square root of 3. So this is 10 times the square root of 3. Anytime you are given a 30, 60 triangle, you know that the hypotenuse is twice the size of the shortest leg, and you know the longest leg is the square root of 3 times whatever the short leg is. Which makes no sense to nobody, but we'll do a few more of them. So let's look at it. I'll give you my base one again. Here's the base one. It is 1, 2, and the square root of 3. 60, 30, 90. Okay, so let's say I've got this triangle here. It's a 30, 60, 90 triangle. The book tells me that. And I know that this is 30. If I know that the longest side, the hypotenuse is 30, the short leg has to be half of it, because from this to this is 1/2. 2 cut in half is 1. So this has to be 15, and the long leg has to be 15 square roots of 3. Yeah, 15 times the square root of 3. Let's do another one. What if I have this? Let's do it with it, laying it down so you don't think that it's always. Here's my 30, 60, 90 triangle. Okay. And this side here is 7 square roots of 3. How long would this side have to be? How long would that side have to be? Logan says, which one you giving me?
The one on the left is 7.
The one on the left has to be 7. How is that? Because whatever comes in front of the square root of 3 has to be that short side. It's divided by that. And then this one would have to be 14. Okay. Is there another one? What else do we have here? Maybe not. You'll use that in some way, shape, or form. For Kyle?
What happens if it's not a 30, 60, 90 triangle?
Then you can't. Then you can't use it. That's why these are special ones. That's why it's special. These are special cases. You can always use this, but the nice thing about a special one is you only need to be given one, and you can figure out the rest. And any other right triangle, you have to be given at least 2 of the sides to be able to figure out the third. Okay. Now, the other The other triangle we're gonna look at is a 45, 45, 90 triangle. So here's special triangle number 2 is this. When you're given two sides of 45 degrees. And this one has to be 90 degrees. And for this one, I am going to pick this side to be 1. Okay? If that side is 1, does anybody know anything about isosceles triangles? Yeah. Opposite sides of isosceles triangles are equals. So in other words, if this side is 1, this side is 1, and that would mean my hypotenuse down here, if I do the Pythagorean theorem, a squared plus b squared equals c squared, 1 squared plus another 1 squared equals c squared, 1 plus 1 equals c squared, 2 equals c squared. If 2 equals c squared, then c would have to equal, Claire? Not 2. If c squared equals 2, c times c equals 2. Not 4, that's 2 times 2. You want to know what number times itself gives you 2. And I can tell you it's irrational. It doesn't make sense, but we use what, Brooke? Right. C is the square root of 2. It is a non-terminating, non-repeating, infinitely long decimal number, but we just leave it as the square root of 2. So, boys and girls, what makes this special is anytime now you're given two 45, 90 degree triangle, you just know that the hypotenuse is the square root of 2 times bigger than whatever either the legs are, which is exciting, I'm sure, to you to know that. So if you're given this, I don't know why I stick with green. If you are given this, here's your 45, 45 triangle. You know, if this is 8, what are the other sides? This side has to be 8, and this side has to be 8 square roots of 2. Because it's whatever this side is times the square root of 2. If you are given this triangle, I guess this is 45, this is 45, 45. Now I'm going to mess with you on this one. What if the longest side, what if the hypotenuse is 10? How long are the other two sides going to be? Cameron? What's that? Oh. Sure. Would it help if I do this? This is the hypotenuse. Longest side is 10. Anybody? Well, how do I go from the longest side to the shorter sides? You have to do what? David? Not in half. Long side to short side. I'm not dividing 8 square roots of 2 divided by half is not that. 8 square roots of 2 divided by half actually is 4 square roots of 2. What am I actually doing? To go from here to here? Not dividing by 2, I'm actually dividing by the square root of 2. That's this. 8 square roots of 2 divided by square root of 2, that goes away. So if that's the case over here, it's not going to be pretty, but my answer is going to be Stuford?
5 square root of 2.
It is not 5 square roots of 2. It actually is going to be 10 divided by the square root of 2. 10 divided by the square root of 2. Square roots are not your friends, and that's not necessarily an acceptable thing, but that's all you're doing is dividing by the square root of 2. And you can't take, these are like having x's, you can't divide a square root of 2 into a 10. The only way you could ever get close to this is you'd have to figure out what the square root of 2 is, which is 1 point, whatever it is, 2 something, 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 non-repeating, whatever it is. Okay, so let me give you another one that has that same thing. You've got this, you've got this. Here's my 45, here's my 45, here's my 90, and I say that this is, I don't know, 5. What will this side and this side be? Same thing we just did, except with the 5. So, let's put it all on the line. Alex,
5 and there's 10 square roots.
where did the 10 come from? To go from the hypotenuse side to the legs, you just divide by the square root of 2. And you can't do anything but say it is 5 divided by the square root of 2. 5 divided by the square root of 2. Which, here we go. This will let you thrill and amaze your friends, children. What about this? Here's my 45. Here's my 45. I know that this is 3 times the square root of 2. How long is this side? Oh, maybe I shouldn't have done it. Wait, let me change this. Maybe this will help. I know that this is 3 divided by the square root of 2. How long is that side? What do I do with the legs to get to that? I multiply by what? What do I multiply by? What do I multiply by? David? What am I multiplying by? What am I multiplying by? To go from here to here, what do I multiply by? Square root of 2. To go from here to here, I multiply by the square root of 2. Guess what the square root of 3 over the square root of 2 times the square root of 2 is? Just 3, because the square roots cross off. Yeah, that was a little deep. I apologize for that. I didn't want to throw you in the hyperbolic